Hello students, we are again here with the chapter household circuits. Uh, we are already half away in the chapter. Today we'll be doing with unit B some essential components of house wiring system. So here I have segregated the entire unit in 6 parts. They are fuse, switches, 3-pin plug, socket, earthing and color coding of wires. So here fuse, switch, 3-pin plug, sockets, these are the components which are connected in the house wiring system along with wiring. So as I have said you about fuse, you have heard the term fuse in the earlier video lecture, isn't it? So this is how our fuse looks like. We'll be learning about them. Then we'll be learning about switches. Alright, then we'll be learning about earthing. So this will be the 3 topics that we'll discuss today. So basically we'll have 2 video lectures on this unit B, where we'll be learning about the essential components. Okay, so in today's video lecture you will be learning about fuse, switches and earthing. Then in the next part 2 of this video lecture you'll be learning about the 3-pin plug. So here you see a plug which has 3 pins, so that's why it is called as a 3-pin plug. Then you will be learning about the socket. This is the place where you put the socket, okay, to get the power. Then we'll be learning about the color coding of the wires. So you know, live, earth and neutral wire, 3 wires. These 3 wires have different colors. The wire does not have a color, the insulation has different colors, okay, so by the help of which we can denote or we can know, okay, the wires are either live, neutral or the earth. Alright, so this is the summary you can see. Okay, you can also see the preview of the unit B. Alright, so today we'll be beginning with fuse, switches. We'll be learning about earthing. Alright, now here you see a fuse. Now I have shown here 2 types of fuse, okay, the basic one and here it is called as a cartridge one. Okay, now what is fuse? Fuse is a safety device, okay, which is used to control or limit the flow of current in the circuit. So fuse has a what property of, or you can say it actually limits, it controls the flow of current in the circuit. Alright, now what or on which principle it is based? Here is the principle, okay, it is based on the heating effect of current. Alright, now I will teach you here what is fuse, where it is connected, how it is connected and what does it do. Okay, about those things I will be explaining here in this lesson. Now you can see that a fuse has 2 parts, okay, the one that you may find in your home as well, it has 2 parts. This one is fixed on the wall or on the circuit or I mean the distribution board, and this is the one which can be removed. Alright, and it gets fitted up here. Alright, now these are the terminals. They are made up of some conducting materials. Usually they are made up of brass, okay, and what is brass? Brass is an alloy of copper and zinc. Alright, are you getting my point? So the fuse has a wire which we call as a fuse wire. Fuse wire is connected to this with to here. So this is how the fuse wire is connected. Alright, and the one which is fixed on the circuit board has connection here with the live wire, and from here it leaves. Are you getting my point? Now in between you can see that there is nothing, means there is no connection between this terminal, okay, and this terminal. So that emptiness, okay, or the breaking of the circuit is now fulfilled or connected by inserting this plug of the fuse here in this socket. Alright, so this is how the fuse is fixed or fuse is connected in the circuit. Alright, then here you have another kind of fuse which is usually used in a circuit board, okay, circuit board. All right, you can find this in your stabilizers, in your inverters, okay, in your, even in your extension board or switch boards, you can find this. Here inside this hollow glass tube you have a small wire. You can see here, this wire is the fuse wire. Now what is fuse wire? So fuse wire is a wire, okay, which is an alloy of lead and tin. Now why lead and tin is used? Okay, you must know that lead and alloy, tin, the alloy of these two has low melting point, okay, low melting point, and it has high resistance. So these two properties are the properties which a fuse wire must have. So a fuse wire must have two properties. What are they? Low melting point and high resistance. Now since you know that fuse wire is based on the heating effect of current, means when the current flows, the wire gets heated up. You know this, the conductor gets heated up. So on that principle our fuse wire is made. So if I have to draw the symbol, so the symbol of fuse will be a rectangular box, okay, connected with the two connecting wires at the two ends, and here you just draw a small curved line here. So this indicates your fuse. Now how does the fuse work in the circuit? See, fuse, okay, wire, I'm just taking the example of this cartridge, okay. So here this is my fuse wire, okay, and this is my live wire, and here, from here the live wire is leaving the fuse, okay. Here the live wire is entering the fuse, and from here, okay, suppose this is end A, this is end B. So from end A the fuse, the current is entering to the fuse wire, okay. Now you know fuse wire has low melting and high resistance. So when the heavy current flows, okay, due to the short circuiting, or due to some leakage of the current, or with some fault in the appliances, there is a probability, or there is some kind of situation when a heavy current flows through the fuse. What happens? This heavy current which is flowing through the wire, due to the high resistance of the fuse, okay, gets heated up to a large extent. So when the wire gets heated up, okay, along with the high resistance, there is another property of fuse wire, that is low melting. So what happens? The fuse wire gets melted. So when the fuse wire gets melted, what happens? It disconnects the circuit. So this is how the fuse works in the circuit. All right, so let me make some space here again, okay. So here you see that what is happening, the fuse wire, okay, which has low melting point and high resistance, okay, what happens when the heavy current is flowing through this fuse wire, okay, due to these two properties the fuse wire melts, so it breaks the circuit, understand. So that is how it has another important property, okay, or you can say a function of a fuse, that is to safeguard the appliances or the circuit in which it is connected. So fuse safeguards the appliances and the circuit in which it is connected. Now let me recall here about fuse. Fuse is a safety device, okay. Here the word is used as safety, okay. Later on when I teach you switch, I will explain you how it is protecting us, okay. So fuse actually it is a safety device which is used to limit the flow of current. For example, if you are using, okay, uh, an appliance, maybe say of refrigerator, and refrigerator needs only 20 ampere of current. This is just an example, okay. So refrigerator is needing only 20 ampere of current. So the fuse that you are connecting in the circuit that takes the power to the fuse to the refrigerator, okay, has a power rating of 20 ampere. So you are using a fuse wire. So because why are you using the fuse wire of 20 ampere? Because you know that your refrigerator needs 20 ampere of current to function properly, isn't it? Yes, but somehow, okay, by some happenings, 40 ampere of current starts to flow in the circuit. So what happens if 40 ampere of current enters to your refrigerator? It will damage your refrigerator. So to avoid that, fuse is connected in the circuit. So now this fuse, which has a wire of 20 rating, okay, 20 ampere, what happens? It allows only 20 ampere of current to flow through it. Now it cannot withstand the current which is above 20 ampere. So when heavy current starts to flow to the circuit, what happens? The fuse wire gets heated up and it gets melted, and hence it breaks the circuit. So in turn, it is now safeguarding your appliances. Are you getting my point? तिम्रो appliance लाई के गर्यो? जोगाइदियो नि त fuse ले. So that is why we called it as a safety device, because it does not allow the current to flow above or beyond the ratings. Okay, understand? So this is how the fuse works. All right, now let's go to the next. As I said you, after fuse we'll be doing switches. So 3-pin plug is here. We'll do this in the next video lecture. Now we'll do the switches. Now what is switch? Okay, switch in the junior class, in class 8 and 9, we learned about different types of switches or keys, isn't it? Plug key, we learned about tapping key, isn't it? Yes, so they are all switches. Now what does the switch do? Switch makes the circuit open or close. Are you getting my point? So if I have a circuit, this is my cell, okay, this is my load, suppose say a bulb, and here I have my key, plug key. Understand? So this is my switch. So switch helps me to switch on or off the circuit, that is to close the circuit or to open the circuit, which means it allows the flow of current, and it can also stop the flow of current in the circuit or through the appliance. Okay, this is our switches. Now switch, as I said you in the fuse, switch, okay, and fuse, both of them are always connected in live wire. Please remember, they're always connected in live wire in series. Live wire in series. You have to remember that switches and fuse are always connected in the live wire in series. Now why is that so? Are you getting my point? So look here. Now suppose this is my one appliance. Maybe you can take this as a oven. Okay, so I'm connecting this to the mains. Are you getting my point? So this is my live and this is my neutral wire. Now fuse is here in the live and switch is also there in the live. Are you getting my point? So now this oven will get the live or the phase connection only when I switch on the switch. Are you getting my point? So current starts to flow. You know that live wire carries the current, isn't it? So current will flow or current will reach to the oven only when I switch on the switch. Are you getting my point? Clear? So if with the span of time, with constant use of this oven, suppose there is some loose connection here in the cable and the live wire is touching the body of the oven. Now there is a probability that if I touch the body of the oven, I may get electric shock, because live wire gives electric shock, which may sometimes be fatal, isn't it? So here, if I have connected my switch on the live wire, what happens? When I put the switch off, this oven is now cut off from the potential that is beared by the live wire. Are you getting my point? So there is no chance of getting shock. But But in turn, if the switch was in the neutral wire, what will happen? In the neutral wire also, the switch will break the circuit. It will not allow the current to flow. But you know that since live wire is now directly in contact with the body of the oven, so the entire body of the oven has now same potential as that of live wire. So even when the switch is off, I will get the electric shock, isn't it? Yes. So that is why your switches and also the fuse are always connected in the live wire. Now let me take the fuse. Now if I connect the fuse also in the neutral wire, okay, now if there is a short circuit here in this appliance, heavy current will start to flow, and in the neutral wire also the fuse will blow off and will stop the flow of current. But still now, since the fuse is connected in the neutral wire, okay, what will happen? This live wire is still connected with the body of the oven. So means the oven is still having the same potential as that of live wire. Understand? So it is not protecting me. So that is why the switches and fuse are also called as a protecting device or protecting gear in the circuit, and has to be connected always in the live wire, so that as soon as there is some malfunction in the appliances, it cuts off the live wire or the potential that is carried by the live to the appliances that you are using. So this is the reason why you should always connect the the switch and the fuse on the live wire. All right, clear? It is not that switch and fuse will not function properly or not function when you connect in the neutral wire. It will do its duty, it will do its job. Switch will close and open the circuit even if you connect in the neutral wire, but it will not protect you. Similarly, fuse when connected in the neutral wire will blow off when there is an overload, or when there is a fluctuation in the current, or when there is a surge circuiting. All right, but it will not cut off the live wire from the appliances, and there is a probability that a person who's handling that appliance may get electric shock. All right. Okay, now we are moving to the last part of today's video lecture, that is the earthing. Here we have socket. We'll do socket in the next class, okay, in the next video. Now earthing. Now what is earthing? Okay, one more thing I forgot in the switches, under the heading switches. Here you have to learn one more type of switch, that is called as dual switch. Dual switches or dual switch, which is also called as staircase switch, okay, or ladder switch. Okay, so we'll learn I will be doing some demonstration on this dual switch. So I'll make one video based on dual switch, which I will upload here in the YouTube. Okay, and when I do that, okay, I will notify you to the group. All right, so that is dual switch, which we'll do in the practical demonstration. Okay, now let's move to the earthing. Now what is earthing? Earthing is nothing but the connection of an electric appliance, or connection of the circuit with the earth. Okay, now how is earthing done? Now earthing, local earthing, we have to say it's local earthing. This earthing is not coming from the company. You are doing this earthing at your home. Okay, so earthing is done near the kilowatt hour meter. So meter ko choma we do the earthing. How do? We dig the earth. Okay, we dig the earth about 6 feet to 9 feet goiro. Okay, understand? So we dig the earth. Now what do? We take a thick copper wire. Okay, we place this thick copper wire in a pipe, insulating pipe or insulator. Okay, and the other end, this end of the thick copper wire is welded to a copper plate. Understand? This is a copper plate. Now copper plate is placed here. Okay, and around the copper plate there is a mixture of sodium chloride, that is salt, and charcoal. And charcoal is carbon. Sodium chloride is an ionic compound which ionizes into sodium and chlorine, and it makes a good conducting layer between the copper plate and the earth. So these two substances are added here to make a good conducting layer. So carbon is a good conductor, you know. Similarly, aqueous solution of sodium and chlorine is also good. Sodium chloride is also a good conductor. So that's why copper plate is now surrounded by the mixture of salt and charcoal, that is koila. Okay, then you fill it with the earth, matole chopa, and this is how your earthing gets ready. Now the other end of the wire is connected to the kWh meter and to the main fuse or the main switch. This is how the earthing is done. Now how this earthing is connected to the appliances? Now earthing is always connected. You must remember that earthing is always connected to the body, the metallic body. So you know all the heavy appliances, maybe geyser, heater, fridge, inverter, your computers, they all have metal casing, isn't it? They all have metal casing. So with the time, what happens? See, you know, these metal casings are painted with some color, okay, paints, and that acts as an insulator, okay. But with by constant use, what happens? This painting on the metals gets eroded. So now you are prone to the metal casing, isn't it? Yes, metal casing of the appliances. So to protect you from getting some electric shock, this earthing or the earth wire now it's connected to the metal casing of the appliances. So you must remember that earth wire. See the three wires which you have in the wiring. Okay, the earth is always connected on the metal casing of the appliances or the metal body of the appliances. So this is how the earthing is done. All right, I hope you understood. Now if you have any doubts, you can text me. All right, now today's assignment is, okay, number 1, where or how is earth connected to the appliance? So you'll say that earth is connected to the appliance on its metal casing, okay, or on its outer body. Clear? Then next one is why the switches and fuse are connected in the live wire. Clear? And number 3, what are switches? Number 4 is what do you mean by fuse? On what principle it is based? Question number 5, fuse wire has or must have what properties? Next question, fuse wire is made up of which material? So these are the assignment for today. All right, so that's all for today. We'll meet again in the next video lecture to learn about 3-pin plug, sockets, and the color coding of wire. All right, so that's it for today. See you in the next lecture.